Hi, so today in this video we're going to be talking about chapter 7.2, which is transformations of the rational function. Last video we talked about graphing the rational function. Now we're going to talk about how to apply those certain transformations. Now if you remember correctly, we have our graph, which is like this. I'm drawing as quick as I can, trying to get these through because it's getting late and my sisters want to sleep. So we've got our little graph. We draw the little window in the middle. We go up 1 over 1, down 1 over 1, and our asymptotes are straight through that box. And then you have a function that looks sort of like this. Super easy peasy if you remember those steps. Now, when we're talking about transformations, let me draw another graph. When we have something like f of x is equal to 1 over x plus 3, I'm sure that it's feeling a little familiar. When we're plussing and it's not right next to the x, like it has to be right in the x, technically when we have a fraction, there are implied parentheses around the top and the bottom. If it's outside though, then it's going to be moving up and down. That's the case with all of the other functions that we found before. Like with our linear functions, we had our plus b, that was our up and down. With our quadratic, we had our plus k, which was our up and down. With our logarithmic functions, we had our plus, I guess it was also k in that case, but we had the log, and then like x plus h, or x minus h, and then plus k. It was always on the outside, and that always moves up and down. So we take our little box. Let me make a new one. We make our little box, and we move that little box up by 3. So 1, 2, 3. And then everything else is the same. Up 1 over 1, down 1 over 1. And your asymptotes go straight through that box. And you draw a little guy like that, and that's your new function. Now, if you have something like 1 over x, and then the x has like a minus 2, it's going to be also very similar to what we've done before. We have our little box in the middle, and when it's right next to our x, either in parentheses or with implied parentheses, it will move opposite how we think it is. So like a minus, we think that we're going left, but actually with our x's, we're going right when it's right close to that. So we're going to move our little box over to 1, 2. I didn't know I had that little guy with me. And then it'll be up 1, over 1, down 1, over 1. Our asymptotes go straight through. And you draw your little graph. Make sure you get the point, actually. Now, let's combine them. If we had something like this and then plus, let's say 1, we would take our little box. We go over right 2, so 1, 2, up 1, and then up 1, over 1, down 1, over 1. And we'd have our little asymptotes that go straight through, like this. And we draw our little things. And that would be awesome. Yeah, there you go. That would be transformations of our graph. Now that we know that, let's come back to Lumen and talk about this. So the way that you graph is you want to graph at where your box is going to be. And we know our box moves down by 2 because we have 1 over x minus 2. So this is our new box. Then you go up 1 over 1. And if you do that in Lumen and click that, your graph will be made. You don't need to do anything else with that. It'll be like that. Whoops. Now it'll say what is the horizontal asymptote. We know that the horizontal asymptote, in this case, the okay, so one thing that is a little bit unfamiliar, we talked about horizontal asymptotes being m over n, right, with like our degrees. In this case, that's sort of still happening a little bit, but the issue is that these are not the same denominator. If we did make it the same denominator, it would feel, it would be the same idea. But when we're thinking about horizontal asymptotes, we don't need to overthink things with m's and n's, because that's a little more complicated than you need to worry about right now. We just know that our asymptotes shift with our box. So our new asymptote, our horizontal asymptote is going to be x is equal to, y is equal to -2. And our vertical asymptote is still going to be x is equal to 0. Hopefully that makes sense. Horizontal is going to be this 2, and then your vertical is going to be the one that's right next to the box. Yep. The graph of y equals 1 over x has been transformed. The transformed function has a horizontal asymptote of y equals -1 and a vertical asymptote at x equals 0. Determine the function whose graph represents the transformed function. So this one, I will say before we start, I tried doing y equals and that didn't work. You have to do f of x. It's kind of silly because they use a y up here. I'm not sure what they were thinking, but they were thinking it regardless, and we have to deal with it. So we'll do f of x is equal to, and we know we have our parent function 1 over x. That doesn't change. The only thing that changes is the stuff that's around it. So I'll switch colors to represent that. We know that we have a horizontal asymptote, which is the side to side, right? So that changes when our x changes, right? No, sorry. Horizontal asymptote is up and down. I always get no. Let me think for a minute. Horizontal is side to side. And that moves when we move up and down. Okay, sorry. So it'll be -1 because when it's outside, when it's the horizontal, it doesn't have any funky sign changes going on. So it'll be this, 1 over x minus 1, and that will be outside of the fraction. This one's telling us to graph the function 1 over x plus 2. So we will have our box, and we move it over by left by 2, because when we have our x, like right by our x, it's going to be kind of funky and opposite of what we think it might be. So now here's our box. We go up 1 and over 1, down 1, over 1, and it will make, it will make the graph with the first point that you put, this one here. And then that would be it for this problem. If we were to think about domain and range, we know that our asymptote is intersecting these boxes. So our domain, it looks like it stops at -2. So -infinity to -2, and then -2 to infinity. Awesome. And then range would be 0 again. So -infinity to 0 and 0 to positive infinity. The graph of y equals 1 over x is transformed. It's shifted down by 8 units. So we know that we have 1 over x. When we're going down, we'll do -8. And we know that it's going right by 6. And also, when we're thinking right, we're thinking positive, right? But when it's by the x, it sort of flips. So we do -6 instead. So this is our new equation. We'll do f of x is equal to 1 over x minus 6 minus 8. What is the vertical asymptote of f? We know that the vertical is up and down, and that will move when we're going left and right, correct? So in this case, our vertical asymptote is going to be +6, which is going to be x equals +6, because we're moving right 6. The horizontal asymptote is going to be -8, so y equals -8, because this negative stays there. It just changes when there's like an implied parentheses next to the x, right? Also, if I'm going too fast, let me know, and I can re-look at some of these problems, either with you personally, or I can make another video that I go more in depth with. I know that I'm kind of rushing through things. I just want to get these videos out because I realize that the final is coming up very soon, very quickly, and I want you guys to have this resource before it is here. So we have the point -8 and -1 over 8. It lies on the graph f of x equals 1 over x. If the graph is shifted up by 3 units, that affects our y value, right? And left by 4 units, which affects our x value. What are the new coordinates of the point? We're going to add the y by 3. So 3 plus -1 over 8 is going to be, we need the same denominator, right? So it'll be 3 times, we'll times this by 8 over 8, which is the same as 1, so we're allowed to do it. It doesn't change the value of things. So we will have 24 over 8 minus 1 over 8. So we'll have 23 over 8 for our y value. And our x value is, it's moved to the left by 4, so we'll minus this by 4, so we'll have -12. The parent function, y is equal to 1 over x, is compressed to 1/3 its size. What is the function f of x? So we have our parent function, which is 1 over x. When we're compressing to 1/3, trying to think if I want to get into this. Yeah, okay, let's do it. So when we're graphing, and we have 1 over x, we know our box, we have our little box here, and we go up 1, over 1, and our asymptotes are here through the middle, right? And it looks like this. When we have a transformation, it'll be like 3 times 1 over x or something like that. What will happen is we will have our box stays the same. But instead what will happen, we'll go up 1 and then over 3. So 1, 2, 3. Let me double check that's correct because I don't want to get... Yeah, okay, so you go up 1 and then over the amount that you're multiplying by, so over 3. If it was by 1 and then down 1 over 3 here in this case. If it was by 1/3, then we're doing almost the exact same thing, but in this case it'd be up 1 over 1/3. So it'll be super squished like that. Nothing changes with our asymptotes. Our asymptotes stay the same. It just sort of makes the graph look a little different. So coming back to this, if it's compressed by 1/3 of its size, we'll do f of x equals 1 over 3 times 1 over x. You want to keep them separate. You can't really combine them because, well, you could combine them, I guess. But typically what Desmos will look for is this 1/3 times 1 over x. I think it probably would work if you combine them, but I'm not sure. The 0.7 and 1/7 lies on the parent function, which is going to be 1 over x. What are the coordinates of this point on the transformed function f? Hold on. Oh, is it the same problem? Give me just a second. Now I'm confused. Okay, yeah, they're the same problem. I just, sometimes when I copy and paste them over, I get confused. Let me just grab a different color. We'll come back over here. So we know that we're compressing by 1/3 of its size. And when we're compressing, and this is the same for almost every single other function that we've covered in this class, be it logarithms, and exponential, and like quadratic, that kind of thing. We didn't really cover it in linear, but it would be sort of the same thing. When we have a compression or a stretch, we are multiplying the y value. So we have our x value, and that will stay the same. And then our y value is 1/7. We'll multiply that by its compression, which is going to be 1/3 in this case, which will be 1 over 21. Now I know that it gets scary when we have weird big numbers like that. You just got to get used to it, I guess. This one says the parent function is y equals 1 over x. It's transformed by shifting the function right by 1 unit, compressing the function to 1/4 of its height, and shifting the function up by 5 units. So we know that we have y is equal to 1 over x. Now again, I'm pretty sure it wants you to use f of x, so we'll just put that there. Y is equal to 1 over x. Let me give myself a little more room. We are compressing it by 1/4 of its height, so we'll do 1/4 times it, and then we know that we're moving to the right by 1, and when we are moving left or right, we usually do the opposite of what we think, so -1 instead, and then we will shift the function up by 5, so +5, and this is our new function. This is what it would want you to do. Yeah, if you have any other questions, please let me know. I will answer as soon as I can. Have a good one.